I'm presenting is a testing proposal for testing framework to port and optimize SIMD library to OpenPower systems. And current problem is there are many SIMD Intel x86 intrinsic function and Intel intrinsic function runs only on Intel, not on OpenPower systems. So we need to port Intel x86 intrinsic code to OpenPower equivalent intrinsic code to run application by good performance on OpenPower systems. But porting Intel x86 intrinsic to OpenPower intrinsic is technically challenging. So obstacle of this project is Intel x86 intrinsic and OpenPower intrinsic are not one-to-one correspondence, and Power ISA vector facility, VMX and VSX are extensive but do not always provide a direct or obvious equivalent to Intel intrinsics. And porting must be correct without error, and error must lead to fatal bug or of application. So, and if we want to measure latency and throughput. And this is a porting wrap structure in case of this intrinsic. And these are definition of type structure, and this is a Intel intrinsic, but it is ported to OpenPower systems, and this is ported like this, and this is inside of porting. And why we need testing framework? Result of intrinsic of Intel x86 and OpenPower ISA must be equal. And if error or exception occurs, this must occur in Intel x86 and OpenPower ISA as same. If result is not same, unexpected or unpredictable bug may be occur, I think. So no reproducible bug may lead to fatal result. So we must test Intel intrinsics and correspondence of OpenPower ISA automatically. So we need testing framework. And for example, if we make a testing framework for this intrinsic and that of correspondence of OpenISA through the random M256D value to intrinsic in Intel x86 and intrinsics of Intel x86 and intrinsic ported intrinsic of OpenPower systems. And this is the structure of testing framework. Random value must be generated by, I think I name it a common random M256D function. And in this testing framework. This testing framework runs on Intel x86 and OpenPower Systems. So, and this is connected by network. So, common random M260D generate same value and compare return M260D value of Intel x86 and OpenPower System. For example, input same A, this A and A, same A, and compare the result M260 value in both Intel and OpenISA and OpenPower ISA. And return value must be compared by common assert M260D value. And this is compare testing framework in Intel and OpenISA must be compared anywhere. And Intel and OpenISA power system must be connected by network module written by Python. I think we cannot write network module by C language, but it is very hard. But we can write network module by Python. We can write network module by Python, I think. And network module is, although network module is written by Python, but testing module will be written by C language extension of Python. And name of testing framework may be Akari, or this is just my hobby. And to port other architecture by using Akari, this test framework name is Akari can be used to port intrinsic to other architecture like ARM. And ARM has different intrinsics too, and need a few modifications, I think. And this ARM version of testing framework need to run Python. And this is a reference. Linux on porting guide, vector intrinsic. This is a reference. And 3, a portable vectable library to C standard mathematical function. This is a source idea of testing framework. And this is a intrinsic site of intrinsic. And we want to build study group and OSS community, and the study group for understanding OpenPower ISA and Intel intrinsic, and community for testing framework. And thank you for watching. Any question?
Konnichiwa.
Konnichiwa.
Thank you for that. In a LibreSoc project, we have to have a test API.
Yes. Test
because
frame.
We compare QEMU with our simulator with the hardware.
QEMU.
Yeah. So we use Python GDB MI to connect to QEMU and control it completely automatically.
Okay, QEMU. I research about it.
PyGDBMI.
QEMU.
I'll send in the chat.
Okay.
DBMI. So this may be very useful because you can connect to x86 QEMU emulator or PowerPC QEMU,
Okay.
and you can set a breakpoint and read the register file.
Okay. Sorry, how to see the chat box? Wait. あれだ。
If you contact me by email, I can provide you with, we have a discussion and I can provide you with the link to the source code.
Okay.
Because we have already done some of the test API for LibreSoc for the power system, because we needed it. We needed it to test the LibreSoc power core.
Okay, thank you. Sorry, what's your name?
Luke Layton.
Luke Layton. Luke Layton. Okay. Luke.
Now, we haven't done anything with x86, well, because we're only doing that, but it may be very useful to.
Okay, this Luke Layton.net. Wait, I will search it.
Yeah.
Oh.
There you go. There's my email address on there. Okay.
Luke Layton. Oh. Any project site out there?
Contact in the middle. Contact LKCL at LKCL.net. Yeah, that's it. Above that one. LKCL at LKCL.net. Yeah.
Ah, okay.
All right.
Thank you.
Sorry. But yeah, it's a great idea to have the comparison to make it the same. I love the idea.
Okay, thank you very much. Anyway, I will send you this slide later. Can I send you a slide later?
Of course, yeah. Oh, that's your.
Are you in OpenPower Slack or?
Well, LibreSoc.
This email address?
Yeah, LKCL at LKCL.net.
Okay,
but,
thank you.
All right, okay.
Wait. Okay, I saved. Anyway, that's all. Any other question? Okay, I will stop.
Thank you very much.
Thank you very much. I will stop share.
Thank you.
Okay. Thank you, everyone.
Thank you.